So hello, ladies and gentlemen, and welcome to our webinar this afternoon. It's 3 o'clock. You should all have a nice cup of coffee or tea in your hand, and we look forward to a very interesting webinar this afternoon. I'm delighted to say that we had over 40 registrations for the meeting, showing what an interesting application of nanomaterials and technology that this is. So without further ado, we'll get started. And if anybody has any problems, if you can't hear me properly, please use the chat function to let me know if you're having some problems, and hopefully we can fix them. So what are we doing today? This is part of a webinar series that we launched called Nano in Action, which is an integral part of the mission of NIA to help promote and showcase nanotechnology and nanomaterials in applications, both in industry and for wider society. And this is a very interesting topic with which we kickstart. So we have three excellent speakers today. We will start with Matthew Tipper from NIRI, who is going to look at the sort of advanced and applied research that leads into industry around nanomaterials within non-woven materials. And then we switch to Gregor Schneider from RAS Materials, a NIA member, who is going to give us a case study of the application of silver into materials. Finally, we come back to our own David Carlender, our Director of Regulatory Affairs, who's going to give us the larger picture and the framework for regulations and standards in which nanomaterials for textiles operate. This is an open webinar, so non-members may attend, but at the end of the presentation session, we're going to unceremoniously kick out all the non-members and go to a closed Q&A session for our members. And obviously, the super easy way to get involved in these discussions as we go through this webinar series is, of course, to be a member. But you will be able to access the recording of this webinar on YouTube, and we will let the members have the slides. On a note of logistics, we're keeping everybody on mute, if that's okay, apart from the speakers, so that we have maximum audio quality. Because usually once we have more than about 10 or 15 participants and they're all on unmuted, the audio quality tends to drop a little bit. So of course there is no such thing as a free lunch, and I am going to step upon your hospitality for 2 minutes to give a small introduction to NIA, so you know what we do and how we work with our members and the wider nano community. So many of you will probably know that, as the name would suggest, we are the Industries Association for Nanotechnologies, and we really support all aspects of innovation as within the nanoscale world as they reach the market. So we want to support products and processes entering into the commercial domain. And we do this through a number of ways. One of our core activities is around helping to create a robust regulatory framework in which Nano operates. We undertake a lot of scientific and business networking and promotion for members so that their materials and their technologies can spread as broadly as possible across sectors, applications and countries. And we also work with a wide number of partners to help build the whole ecosystem in which nanotechnology operates, as it's a relatively young commercial sector and a lot of work is still needed to create a robust infrastructure in which it can be truly commercially successful. We're based in Brussels, but we have a team split across Europe. And so we have hopefully enough skills to address most aspects of the support for nanomaterials. This is just a really quick look at our members, or a few of our members, and you can see it's extremely diverse. We have the large multinational companies involved who have all sorts of sectoral applications for nanomaterials and in all sorts of countries, and they are incredibly useful to look in the long term for strategic business planning around nanomaterials. We have a very significant number of small to mid-sized companies, particularly within the nanomaterials production area, with applications incredibly diverse. So we're looking as far as nanomedicines, through to LCD screens, through to materials producers, through to quality assessment and safety assessment. There is a huge variety in the commercial spheres in which nanomaterial producers and users work. We also have an increasing number of research members because they're incredibly important to ensure the successful translation of materials work and safety work into commercial development. And as you can see, we have people as diverse as IMEC, based in Belgium, through to CEA in France, and then more straight universities such as the University of Birmingham and Imperial College London. So you can see there's a quite broad selection of members that take part. And of course, we would not get very far without the specialist service providers within the nano community. And they, again, are very diverse, each of which bringing a very specific skill that we can share between members, which is always very useful. And as with many other trade associations, we have other associations as members of ourselves, particularly the Czech Nanotech Industries Association, and I'm delighted to see them here today. Plus Austria, Sweden, and Canada involved also. So we're always delighted to welcome new national associations into our family. But a really super quick look at what we do in more detail. As I mentioned, our regulatory work is one of the core aspects of what we provide to members and the wider community, because as many of you will know, the regulations around that impact nanomaterials are changing all the time. And we're seeing more nano-specific text coming into play. And it's incredibly important for our members that they know what is coming, whether it's in the EU or the US or in Asia, so that they can position themselves correctly and get to the market as smoothly as possible. So we work across a number of different activities there, very much driven by the priorities of members. We also, as part of our business and scientific networking, run items such as the Nanotech Innovation Council, where we ask members where the latest disruptive technologies are that are impacting their development to market. We collaborate extensively with other industry associations, particularly those in Brussels. So we look at links into the metals industry, automotive, medicines. It's incredibly useful to go through those industry associations. We also run a funding tracker, so we're constantly looking for where members might try and find funding to support their innovation development. And we're part of the Industry for Europe Coalition, which is a coalition of about 130 industry associations seeking to support a more formalised industry policy for the EU. And finally, we're in a number of collaborative projects that operate really all around the ecosystem for nanotechnology. So it's in terms of business support, such as you see in the Inspired project, but they're also looking very much at the safety, regulation and standards that are associated with nanomaterials and nanotechnologies. So through representing industry in these projects, we can help to build a more commercially robust framework in which nanomaterials can reach the market. A quick look at the activities we have coming up. You're actually sitting in one of those activities now in the Nano in Action open webinar series, and we're looking forward to the next sector webinar to take place probably in February 2019. We've also launched a Nano in Business open webinar series, the first of which will be in January, looking at really the business and economic drivers behind nanomaterials development. So our first one in January will look at the actual production of nanomaterials, and the one next after that will look at the growth of service provision within the nanotechnology sector, as both are incredibly important aspects of a successful economically performing sector. And in terms of face-to-face meetings, we're going to bore you with information about our 8th annual symposium next March in Brussels. And this is a one-day day of networking and business and scientific development, and it is open to non-members, and we would be delighted to see people there. It should be a good peer-to-peer networking day with plenty of opportunities for discussion-driven sessions. So, of course, how do you take part in this? You should, of course, join us. And our membership is open to lots of different types of organisation if you're not one already. We undertake a lot of networking and collaboration across the membership, and members very much drive what we do and how we do it. So hopefully we are serving them to the best of our capacity at all times. And in return, we will promote members extensively across the global stage and in projects to help ensure we always have great examples of nanomaterials and technologies in action. So how can you get involved? If you're not already signed up to the newsletter, you can do that through our website, or you can follow us on LinkedIn and Twitter. And of course, just come and talk to me directly if you're interested in taking up my membership offer. So that note gives you your whistle-stop tour of NIA and its services and what it does with members. So I will move swiftly on and welcome our first speaker. If you will allow me, we've got some excitement to change over speakers, but I will hand over to Matt from NIRI while I'm handing over the screen, and he can introduce himself and get on with our first presentation of the afternoon. So Matt, you should be receiving your invite now, and we can look forward to seeing your screen switched on shortly. Okay, yeah, I am just sharing it now. Lovely, and I can now hear you, which is good. Excellent. So thanks very much, Matt. Please take it away. Okay, well, good afternoon, everybody, or good morning or good evening, depending on where you're dialing in from. My name is Matthew Tipper. I'm the Business Director for the Nonwoven Innovations Research Institute, and we're based in Leeds in the UK. So NIRI is an organisation that does non-woven research and development, and today I'm going to talk a little bit about how we apply nanotechnology in non-wovens. So I'll start with just a brief introduction to NIRI. We're a leading research organisation in non-woven and textile engineering. We were spun out of the University of Leeds in 2005, really to focus on applied research and development in fibrous materials. So we're not doing fundamental university-based research. We're bridging the gap between university research and commercialization. And we really apply our expertise by joining the academic excellence that you'd expect from a university with industrial expertise that you'd expect from a commercial organization. And we're using those two opportunities to create something unique. And we're quite diverse in what we offer, but we split what we do into understand, develop, and deliver. So, you know, what their materials are, what they're composed of, and why they work. We have small scale equipment for making non-wovens and nano-based fabrics, and we can use that equipment to do technical feasibility and proof of concept work and prototyping, developing a specification that will work in the end application, and at the end of that process to full manufacture. So producing validation and specification data, and really scaling things up at full scale from laboratory. So NIRI's expertise really lies in textile engineering. So most of us have some form of textile engineering qualification and experience in the industry. So we're really exploiting understanding how the fibers are made and composed, and how we might process those to create a 3D architecture that delivers the performance that people are looking for and that really targets the application. And since 2005, we've been quite busy. We've successfully completed over 400 projects for over 150 different companies. And we're combining the academic rigor and the industrial excellence to generate IP in your field and own. And because we're also not publishing like a university would do, we're able to offer this on a confidential basis. So we believe confidentiality is at the root of everything we do. So I'll introduce what a non-woven fabric is and how it might differ from a woven or a knitted fabric, which people are more understand a little bit more. So, if we look at a woven fabric, you can see from the picture that the yarns are interlaced, they're held together mechanically. If you look at a knitted fabric,
then they're intermeshed. You've got lots of intermeshing loops. But a non-woven is more of a random laydown of fibers or filaments, which are then bonded in some way. So you miss out any yarn making preparation. And as a consequence, non-wovens are a lot cheaper than traditional textiles. But it also gives us an exciting opportunity to engineer in a lot more properties, because there are a lot more processes which can be considered as non-woven processes. So how do we introduce nanotechnology into non-wovens? Well, the first way you can do it is really to create nanofibers themselves and deposit them directly as a web, which you can then form into a fabric. And the second way is to use the non-woven as a carrier substrate for nanomaterials. And both of these techniques are used regularly in industry for commercial applications. So if we take the direct deposition of nanofiber, perhaps the most common method is electrospinning. And here we're dissolving a polymer in solution, and then as we're extruding the polymer, we're hitting it with a high voltage electric field. The field is then grabbing the polymer and stretching it and starting to form filaments. And there's two main methods used in industry at the moment. You can do it from a cylinder, or a newer method is to deposit the polymer onto a wire and then spin from the wire. And there's probably well over 40 installations doing electrospinning on a global basis. And if you look at the results of that, you can see on the left-hand side there, there's a nano web that's supported by some larger fibers. So because the fibers are inherently weak, they usually need to be supported by another substrate, which is often another non-woven. Fiber diameters are typically in the range of 200 to 500 nanometers. Another method of making nanofiber, which has received some interest and some commercialization activities over the last 5 or so years, is force spinning or centrifugal spinning. This is where we can dissolve the polymer or melt the polymer in a high-speed rotating vessel. And with the centrifugal force, the polymer is fed out through an orifice, which, with the inertia, the rotational inertia, stretches the filament into nanofiber. So this technology is quite exciting because you can deal with melt polymers as well as polymers that you've dissolved, and fibers typically range in the diameters of 200 to 500, but can be as large as 1,000 nanometers. And an area we're seeing some interest in commercially now, it's probably even less well developed, is called solution blowing. So this is a relatively simple process where we're dissolving the polymer and we're extruding it. And as we're extruding it, we're hitting it with a high pressure gas flow. And we're stretching the filament using that gas flow. So it seems to be a higher throughput technology. So that's generating quite a lot of interest. So they are the main methods of directly depositing nanofibers. And if we look at some of the applications that those structures are obtaining, we have products for protection. So that these can be sound absorption or protective clothing against threats such as chemicals or biological warfare agents. There's also sensor applications for detecting chemical agents. There's been quite some effort in the medical field. looking at tissue engineering and growing cells, or growing medium for cells, and implantables, delivering drugs, improving wound dressings. In the energy field, we're looking at battery separator, mosaic cells, and getting into fuel cells. Wearables also. So we're seeing commercial applications in sports apparel, replacing membranes such as Gore-Tex, fiber equivalents. But perhaps the largest area within nonwovens is filtration. Again, for membrane replacements, but looking at filtering air, oil, fuel, beverage filtration, even going into pharmaceuticals, and also blood filtration. So there's been work ongoing in that area for probably 40 years, and it continues as filtration is able to extract the benefits from the increased surface area of nanofiber. So that deals with direct deposition. So now I want to go on and talk about how we might use a nonwoven as a carrier for other nanomaterials beyond in fiber form. And NERI's been developing jointly with a company called Optimum Technology, a technology for injecting nanoparticles into fabrics. So we can do it dry, or we can do it as a wet slurry into a preformed fabric, and then we can retain those nanoparticles within the structure of the fabric without any adhesive chemistry. And it's pretty much compatible with most materials, and we're looking to make it a very, very quick process. So to be able to be injected at some commercial line speeds of nonwovens, which can be up to 600 meters a minute. And we can add functionality with nanoparticles. So they necessarily get in a fiber. So by combining the fiber with the nanoparticle, we can start to add interesting properties. So these could be anything from liquid absorbency and retention, the absorption of odor or volatile organic compounds. We can add antimicrobial or biocidal function, acoustic and thermal management. We can make materials more flame retardant. We can make them magnetic. We can increase their bulk thickness or characteristics of different waves. So we can use those particles to functionalize the fabrics, and the fabric is really the delivery mechanism for that function. So this is our process. We start by scattering the particles on top of the fabric, and the particles are forced in using a unique technique, and then we apply a heat and pressure process after the particles are forced in there to lock the the particles within the fibrous structure. So this requires the pore size of the fabric to be controlled and to be matched with the particle size that you want to put in there. Obviously, if you have very large pores and very small particles, then it's not going to be retained. So there needs to be some matchup between the structure of the fabric and the structure of the particles. So the injection process is a continuous process. So energy is transmitted using ultrasonic waves to mechanically force the particles into the fabrics. And what it means is the particles are driven into the pore space of the fabric. So most nonwovens are sort of 85% air, and we're using that space to fill with the particles. Because we can do this, and we're using that space between the fibers, it means we can create fabrics of very, very low thickness, but very high particle loadings. And you can see from the picture there that the particles are physically retained under the fibers and can't escape. So I've mentioned a lot of functionality, but one of the areas I wanted to give you an example of is air filtration. So we were particularly interested in metal organic frameworks to remove volatile organic compounds from air. And the focus of this was to look at domestic air purification, which is certainly a growing area of interest for consumers, particularly in the Far East at the moment, but also in Europe and the US. So metal organic frameworks are crystalline materials. They're a subclass of coordination polymers. And they have a highly micro and nanoporous structure with enormous internal surface area. Essentially, they consist of metal ions and organic ligands. And because of the way they're constructed, you can get a huge variability of different structures and compositions. So if you're familiar with activated carbons and zeolites, they've got internal pore structures like those, but they can be engineered in a much better way to create a wider variety of structures and also much higher surface areas. So they can be 4 times the internal surface area of an activated carbon. And MOFs are becoming interesting to us because of their commerciality. So there's been some process developments over the last few years that has brought the price of MOFs down to an area where they're now starting to become commercially attractive and commercially usable. And there are commercial products out there that have MOFs included. So our interest was particularly in volatile organic compounds, which are compounds that easily become vapors or gases. They're released from burning fuel and also from many consumer products, and they're well proven to be bad for human health. So we had a look to see what the common VOCs were for internal air. And of particular interest were ammonia, acetaldehyde, formaldehyde, nitrous oxide, ozone, sulfur dioxide, and benzene. So we made a nonwoven and we loaded it with activated carbons and MOFs using our particle infusion technology. We managed to get particle loadings approximately 50% in weight, and then we subjected them to analysis using dynamic vapor sorption against ammonia. And the dynamic vapor sorption technique, it's a fairly simple technique. We're taking a gas, we create a vapor of the ammonia, and we pass that into a humidity regulated chamber. And we measure how much is absorbed by weight. So there's a microbalance that monitors the changes in weight. And these are the results that we got. So what we have on the left is the change in mass, which is represented by the red lines. And we have the target relative humidity on the left, which is represented by the blue lines, and we've compared activated carbon at the top and the metal organic framework at the bottom. Essentially, what we're seeing is increased ammonia absorption compared to the activated carbon. So we believe with MOFs that you can get a better air purification product into the market and improve the air quality in internal environments. So just to summarize, nano nonwovens can be produced by either direct deposition of nanofibers or by using the nonwoven as a carrier for other nanomaterials. Our nanoparticle injection technology has the potential to offer a fast method of directly incorporating these nanomaterials into a carrier nonwoven substrate that has been specifically designed. And we discovered it's feasible to impregnate nonwovens with nanoparticles such as metal organic frameworks, which are showing really good promise in reducing VOCs from air streams and could help to improve interior air quality. So that's the end of my presentation. I'd like to thank you all for listening. And if you have any questions, I believe the members can ask me at the end. So thank you.
Thanks very much indeed, Matt. That was extremely interesting, and it highlighted a number of areas that I think our members and wider producers of nanomaterials would actually like to consider in terms of novel ways in which to apply their materials into application. It certainly opens up some food for thought there. So I am going to go without further ado to our next presenter, who is Gregor Schneider from RAS Materials, who is going to present an industry case study of how they applied their own nanomaterials into a textiles application. So I'm just going to pass the presenter over to Gregor, so hopefully he will switch his screen on very quickly. Yep, and we have it there. Very nice. Thank you, Gregor. Do you want to say hello so we can check we can hear you?
Hello, everybody.
Yeah, perfect.
So I hope you can hear me.
We can hear you very well. Thanks, Gregor. So take it away, please.
Yes, so thanks a lot for the opportunity to show you some of our, yes, I would say, one of the products or the developments nearly 10 years ago, or more than 10 years ago. So it's one of our oldest products, which is a textile that incorporates nanosilver particles. And today I want to share some of our experiences, show you what products we have, how these nanosilver particles have been incorporated into the textile, what our customer is claiming then, and of course at the end, a little bit as in connection to David, show you the regulatory and you can say the safety assessment of such a textile containing nanoparticles. We ourselves, we are a small company. We have just 20 employees, but we have 4 of those business units. Is the one that I'm the head of. This is silver nanoparticles for antimicrobial functionalization. This is called RG Pure, which is an additive to incorporate in mostly every surface and materials you can imagine by using different formulations of particles. We are not only, or the textile applications are one of the smaller parts of our business, more or less surfaces for disinfection purposes, ceramics, medical devices, and food contact materials are the fields where we are active as well. And you can imagine in all of these areas, we have different claims and different strategies, what antimicrobial additive wants to bring into these products. But today we are going to focus on the textiles, and just for you for imagination, what our product looks like. You see, according to the European nanomaterial definition, we have a clear nanomaterial. We have particle size below 20 nanometers, and we have created a bunch of formulations. This means we are sure that the nanoparticles are always, you can say, in certain dispersions or liquids to avoid nanodusts or the release of nanoparticles, and to instigate the customers, the companies to use dispersions which are more easy to use and more easy to bring the nanoparticles into the materials. The benefits we want to have is, of course, an antimicrobial surface, an antimicrobial activity, which means that you have a release of silver ions from the embedded silver nanoparticles. You see it here in this scheme. We always assure that the silver nanoparticles are strongly bonded into the material, which might be a lacquer or coating chemistry, or in our case, a polymer textile. The silver ions are released, and those silver ions then kill or inhibit the bacteria or the other microbes from growing. And one of the benefits of nanosilver is that having this silver depot from this nanoparticle, you have a lifetime long activity. This means silver ions can permanently be released from this depot. And of course, you know that silver is thermostable, which means that such kind of biocidal substance will survive the thermoplastic production that is taking place, for example, in textiles that I am presenting afterwards. And what is important as well is that silver is not only active against bacteria, but also against fungi and yeast. So we have an excellent antimicrobial protection of the products where the silver is incorporated. For textiles, we have a little different way how we incorporate the nanoparticles than we have shown before, or we have seen before. We use one of our base concentrates to bring the silver particles into polymer granules, polymer pellets, which then form a so-called master batch. This is a polymer that contains a higher concentrate of the silver nanoparticles than we have at the end in the fiber. And if you then mix this master batch with the raw material, and then you will produce a fiber via the normal and the state-of-the-art thermoplastic fiber production process, you will then get nanosilver containing fiber, which means, and which is very important to distinguish to the other type of application of biocides, we have the silver inside the fiber. We have, you can say, molten it into the fiber, which gives it a unique durability and stability compared to just textile finishing or textile coating. And this fiber, from this fiber at the end, antimicrobial textiles or cloths have been produced. Why do we use nanosilver? This is a very important question after this, you can say, very hard discussion the last 10 years about nanotechnology. We have seen that by using nanosilver instead of bulk silver, you can spare a lot of active substance that is needed for an active product, compared to, for example, using a coated fiber that has 20% of the silver on the surface. You just need 1/1000th of this silver amount in a PET, in a polymer fiber for the same activity. So this means by using nanomaterials, you can conserve a lot of resources, and this is one of the benefits of nanotechnology in this field. So let's go to the application. The company Freudenberg has, a few decades ago, I think, invented the so-called microfilament fabric Evolon, which is a non-woven with a special geometry, which makes it very, very nice for dirt removal and cleaning purposes. But you can see on this SEM picture on the right that we have a challenge here, because we are using, or we are talking about microfibers. Microfibers just have diameters of around about 10 micrometers. This means if you do want to incorporate some biocide active substances, you have to use the ones with a particle size that is lower, of course, than the diameter of the fiber. So micro particles or other bigger particles are not feasible, because otherwise you would not be able to create this fiber. So the choice was to use nanoparticles, which you see here with the white and red dots, which is such an illustration. But the decision to use nanoparticles as the active substance inside these fibers was based on the particle size. So you are able to still to spun the fiber and use an biocide substance here. And important is the silver is inside the PET component of the fiber, which is a mixture of PA and PET fibers. At the beginning of the development, of course, it was necessary to first of all to check if these nanoparticles are incorporated into the fiber, and after that to check the antimicrobial efficacy in the laboratory, which means you had to do a certain industrial or international standard tests, because normal RG diffusion tests, other things like that, are not suitable for assessing the antimicrobial efficacy. You have to use newer standardized methods, for example, the ISO 27743, to check the antimicrobial activity of the fiber, of the textile finished after the production. And we have seen, or Freundberg has seen, that incorporating our nanosilver into the fiber leads to a very good bacterial reduction, which is 3 log units. This is, I know, or I think you are more familiar with this. This is a removal of 99.9% of the bacteria. And this was a very good result for such a textile, because the silver amount that is used in this textile was very low to keep it economic, but we still have a very nice reduction, which also comes from the microfiber geometry, which gives a high surface for the silver ion beads. The second important parameter was to check that this bacterial reduction is still present after more than 400 industrial laundry cycles at 60 degrees. Because as you will see afterwards, the marketing and the claiming was based on this permanence of the efficacy. And of course, different bacterial test strains have been examined to assure that the activity is very general. Just say one of the marketing claims from the Veleda homepage, and you see now it becomes more clear why Veleda or by Freundberg wants to have this 400 times of permanence, because this cloth, skip back, this cloth you see here are professional cleaning cloths. And normally those professional cleaning cloths are used over the day, and then they have to be washed and tumble dried. But by using this particles inside the fiber and having this very high activity, you can avoid, or you can omit the tumble drying after the washing, and you can store this cloth in a wet condition, in a moist condition, which means you spare a lot of money, and you get an amortization of the product after 2 years by saving the money from the avoiding of the tumble drying. This leads up to several hundred washing cycles until 3 years, and after that the cloth is really destroyed and you will throw it away. This, you can say, conserve of resources was tested in the research project, which was called LICARA, but not only the life cycle assessment was done in projects, we also checked the safety assessment of such a product for the ecological endpoints and also for, you can say, human toxicology. And now I want to show you some of the results so that you see that after the development of such a product, you will have such kind of homework to do to assess the safety of such a product, and that is, you can say, doesn't harm the environment, and that you really have an environmental impact by using these products. So here we go. First of all, the life cycle assessment has shown that by avoiding or by omitting this tumble drying of this cloth, you can have up to 50% energy conservation, and the environmental impact was improved around about 30%. So using nano silver particles inside a fiber compared to a conventional cloth without nanoparticles gave you this better environmental impact, and shows that you can use nanotechnology for, you can say, saving money, costs, or having a better environmental impact. Secondly, after discussion, we have seen that we have to show that the exposure with nanoparticles that we see or that we don't want to have from such of a material has to be shown by several you can say scientific investigations. And on this slide you can see some of the results that you have to be aware that if you incorporate nanoparticles into a material, it does not automatically mean that you are releasing nanoparticles. You remember there's this figure before, and here you have some SEM picture as well. If you have abrasion or something like this, the polymer or the lacquer will not release nanoparticles. It always will release some microparticles of the textile of the polymer, incorporating the nanoparticles. So you can say just an abrasion of nanoparticles from polymer or lacquer matrix is not possible. The other thing was to check, is silver ion releasing textile like we have here, is it a threat to wastewater treatment plant or to the environment at all? And is the use of nano silver dispersions, nano silver master batches during the production and in the household, is there any risk for the people that are using it? And we have seen in our risk assessment that for human risk characterization and also for environmental risk characterization, we have always acceptable risks, which means that no environmental compartment is harmed by using this nanosilver, and no worker or user of these textiles is harmed by the nanosilver particles inside this textile, because the exposure is very low and the toxicological profile is very good, which means that this nanosilver is not as toxic as it was expected. At the end, I just have a slide with a summary of the regulatory status of such a product, because if you have a treated article like we have it here, that has an antimicrobial claiming, the biocidal products regulation applies. And this means that you have to use as active substance that is complying with this regulation. And here I've listed you can say all the facts, so that you see that the nanosilver is marketable inside the European Union, so that it is accepted biocidal substance, which means that the textile, the treated article that incorporates these nanosilver particles is also marketable and can be used inside Europe for this purpose. Now I think given you a small imagination of the development and of all the things around such a development for a company that wants to develop antimicrobial products. And I hope you have enjoyed it, and I'm open for questions at the end. Thank you very much.
Thanks very much indeed, Gregor. That was really interesting, particularly from a small company's perspective of not only the technology of integrating and validating the efficacy of a nano-enabled cloth, but also the exposure assessments that you undertook to prove that it was safe in the long term. In fact, the cloth wearing out before the nanomaterial being exposed. So we're going to have some more technical issues now. Sorry, I'm trying to talk and do things at the same time, and that doesn't work. But we're going to now hand over to David Carlander of NIA, who is going to paint the picture of the regulatory scene around textiles and the use of nanomaterials. So I'll let David introduce himself while I actually come and get my own screen back again so we can see David's slides.
Thank you very much, Claire, and good afternoon to everybody. Indeed, in the interest of time, I will hope to also not manage to be more or less in time of the foreseen timeline that we're having for the webinar. So I will give a few examples, and some maybe a bit repetitious. And let me just hear. Claire, are you giving me the?
I have not given you the screen. I've got it myself. So just shout when you want to change slides.
Yeah. So please change slide. Thank you. So a few applications of nanotechnology in textiles, and the previous speakers have all touched upon them. I think you may also have seen or heard about these previously. But there are, of course, a number of the interesting applications that we see there, including antistatic properties, as well as thermal regulations of color modifications and active release of chemical substances. For example, of both including drugs and pesticides have been shown in various possible applications. Indeed, not all of these possible applications are currently on the market, but they are raising a number of very interesting research prototypes. Next slide, please. So there are, as we have basically heard, there are two main issues on how to incorporate nanomaterials into textile fiber applications. You can have it into the fiber, as we've seen with the previous application, and you can also have a coating of nanomaterials onto the fiber, and that is basically a finishing coating process. And some of the advantage of using the composite is that you very often can use a very low nanomaterial incorporation, and this very firm incorporation results in improved durability and functionality, as we've just seen in RAS presentation, and also very limited exposure of actually nanoparticles from the composites. However, when you're applying the finishing coating applications, which is mainly due to dipping the textile into a solution or padding it, also including printing or various types of coating process to adhere the nanomaterials to the fiber, it is in general reduced durability of this process, and they may more easily wear or wash off, and therefore also provide a likely exposure. Next slide, please. Some of the examples that you may have seen, some of these rather traditional materials that you see on the left-hand side in the column, silver, titanium dioxide, etc., all the way down to nanotubes and graphene, and the various functions that these materials are providing, as indicated also on the earlier slide, such as antibacterial functionality, the electrical conductivity, UV protection, self-cleaning, water and dirt repellent, and so forth. Next slide, please. Some of the stability of the nanomaterials within the textile fiber itself is obviously then depending on how they are bound to the textile, either if it's the composite or just being coated to the fabric. But there are also, of course, a number of external impacts during its life cycle that affects the stability and the also possible release of the nanomaterials from the textile itself, whether it's from abrasion, mechanical stress, UV radiation, and a number of body fluids, as well as water, of course, and solvents used, as well as temperature changes, can also have an effect on the durability of the nanomaterials themselves and their connection to the fiber. Next slide, please. So moving over to some of the regulations, just touching in general, as some of these areas are not fully as regulated as in other areas. So I'm going to touch upon a number of regulations here. So we have the general consumer protection by the General Product Safety Directive, which is in place in the European Union, and that is there to protect consumers. And it's basically seen as the last or first line of defense, however you'd like to approach that. And this directive, which is being implemented in all member states, provides for a general requirement to supply goods that are fit for purpose and do not present a disproportionate hazard to the end user. So therefore, if there is a hazard, the end user needs to be warned, and there is a need to propose risk management measures. It's basically rather final activity. Next slide, please. There is the European Union Textile Regulation, which does not really cover the hazards of textile materials themselves being tested, but it is the EU regulation mentioned here is the one on textile fiber names and related labeling. And this regulation do not specifically mention anything related to nano, and the reason mainly being it's that it's not Nano is not, how can I phrase that, applicable under the competence of this type of regulation. Next slide, please. There are also a few limitations of using nanomaterials in textiles in place, and they both refer to, or they refer to the organic and eco labeling of various products. There is the global organic textile standard. The current version is from 2017, but the incorporation of nano even came in 2014, and that textile standard directly prohibits inputs containing functional nanoparticles, meaning particles with a size smaller than 100 nanometers. And then there is the European EU eco-label for textile products, and the latest decision from the European Commission establishing the criteria specifically indicated that biocidal products shall not be incorporated into fibers, fabrics, or the final product in order to impart biocidal properties. And common examples are also provided in this decision, includes nano silver. So in practice, that means that a RAS product will not be able to have the EU eco-label, although it still imparts a lower energy requirement during the product life cycle, as we just saw. Next slide, please. Overall, just one slide to discuss briefly the nanomaterial and textile safety issues. Obviously, as these nanomaterials now will fall under REACH and other pieces of regulation, such as the biocidal product regulation, the hazard exposure data and chemical safety reports are based on information provided under REACH. And for most aspects, the conventional exposure routes for workers and consumers, the three ones being oral inhalation and dermal, were obviously for the workers. There is a potential risk of inhalation during the manufacturing and handling process of textiles with nanomaterials, depending as well on the actual how the nanomaterials were incorporated, as shown previously, as well as the obvious one being a dermal contact while wearing or working with the material. And that exposure route is, of course, applicable both for workers and consumers. There are also some publications looking at nanomaterial skin penetration. I think it's important to mention this here, that there are indications that nanoparticles smaller than 4 nanometers can penetrate intact skin, and sizes between 4 to 20 nanometers can potentially penetrate intact skin. And moving up in larger sizes, there are some indications that 21 to 45 nanometer particles can potentially penetrate damaged skin as well. Very much of this information is also coming for work on cosmetics, where the nanomaterials are directly applied to the skin. Next slide, please. This is just a short overview on various aspects of toxicity screening in general, so it's not fully applicable for textiles, where the OECD has the developed test guidelines on how to test materials, and there are a number of current revisions to specifically address nanomaterials of OECD test guidelines, because the usefulness of using OECD test guidelines is, of course, that once you have performed them, they fall under the mutual acceptance of data. So the data generated under the OECD test guidelines can also be used in other jurisdictions. And then we have REACH, where ECHA is developing a number of guidelines, as well as there are also a number of standards, both from their ISO as well as SEN, the European Standardizations Body. Next slide, please. I'm going to move a bit faster now, so you can skip this slide and do the next slide, just to mention that the 2000 European Commission definition of nanomaterial was scheduled to be revised. So if you move to the next slide, I don't know if it stopped, if it's only me here. Yes, there we are. It was scheduled to be reviewed, and you may or may not have heard that this review is, the public consultation of this review is now put on hold by the Commission due to the upcoming elections next year to the Parliament and to the new Commission. Next slide, please. So moving over to REACH, shall we do the next slide immediately as well? I'm sure many of you have also are aware that the REACH, the registration of chemicals in the European Union, the annexes to REACH have recently been adopted by member states to include, among other things, a definition of nanoform in REACH. And this definition is based on the 2011 recommendation. These modifications of REACH annexes, the general issue is that there's a general clarification that if nanoforms are covered by the registration, they must be addressed, assessment and conclusions documented, and appropriate risk management measures must be identified. And for example, the physicochemical properties of nanomaterials has to be considered, such as their size, the particle number size distribution, surface functionalities, etc. And all of these specifications are introduced in very many of the REACH annexes. So there are changes in the REACH annexes 1, 3, and especially in Annex 6, where the definition is included, all up to Annex 12, which are modified to certain parts. Next slide, please. Because of this, the European Chemicals Agency will update a number of its current nanomaterial guidance documents based on the adopted REACH annexes modifications, but they can only do this, which is referred to as the PEG process, after the publication in the official journal. Next slide, please. I think we'll skip this slide, and for the next slide, the important thing is to see that there is indeed a number of nanomaterials that have already been provided as dossiers to the in the REACH registration, and currently there are about 35 dossiers that have used the tick box, and you can see a number of the examples here, and a number of these are also relevant for treatment and use of within the textile sector, such as aluminum oxide, silver, zinc oxide, titanium dioxide, and carbon nanotubes. Next slide, please. Because it's also related to some upcoming work and may also be applicable for well, will certainly also could be relevant for textiles. I included the upcoming work on the Basel Convention on the transboundary movement on hazardous waste, which is under the United Nations. They have an ongoing work on waste containing nanomaterials, and a report from the 24th of August is currently up for commenting, and comments should be provided by parties to the Basel Convention by 31st of January 2019. And the report itself is on issues related to waste containing nanomaterials and options for further work under the Basel Convention. So considering the full life cycle assessment as well as the circular economy, this is something that is also relevant for textiles eventually. Next slide, please. On the European Observatory of Nanomaterials, there was recently a nanomaterials pigments report, and the reason why I mentioned this is, of course, that a number of pigments also used for dyeing textiles may indeed be basically in the form of nanomaterials. And I think the important part is here on the next slide, please. There is a statement from this report that indeed, and what we've seen also earlier in basically also from the presentations by Gregor and RAS, that the dry pigments presents the highest concern because it can easily be inhaled and ingested, and it is what we've seen previously in other experiments as well. But I think here's comes to the important statement that exposures to nano-sized pigments that are integrated into polymers, paint or coating matrices are not thought to be significant, and the risks to the consumers from such uses are low, and indeed that is also what we are seeing. Once introduced into composite, there is indeed very low exposure. Next slide, please. And this is my concluding slide, also just for information that the US NIOSH, the National Institute of Occupational Health, is currently having a consultation related to nanosilver, but that is nanosilver and health effects in an occupational setting, where they are proposing to have a lower recommended exposure limit to processes that use silver nanomaterials. And the deadline for comment on this is 30th November 2018, so about 2 weeks' time, and NIA will be part of this. But if you are an interested industry or as well, you can. It's a public consultation, so everyone can provide their comments. And with that, I think it's the last slide, and I'm aware that this was rather fast and it took a bit longer, but bear with us. Thank you very much.
Thanks very much indeed, David, for that speed walk through the regulatory and standards aspect of nano within textiles. And that brings us very neatly to the end of the presentation part of this webinar. So I would very much like to thank all of our presenters for an extremely interesting insight into the technologies that are driving the incorporation of nanomaterials into and onto textiles, plus their applications in real life products, and the changing regulatory environment in which these materials now find themselves. So I'd like to thank you very much again to the speakers and for our members and non-members for taking part. For everybody, the YouTube, we've recorded this webinar and there'll be a version popped on YouTube as soon as possible, probably first thing tomorrow. And we'll write to all registered delegates to share the link for that, plus the introductory slides. And now I am going to unceremoniously kick out all of our non-member participants, and I apologise in advance for that, as we go to the NIA member presentations and discussions. So you are obviously quite welcome to take yourselves out of the loop, but I will come round and switch off the various participants. So we'll just put ourselves on pause for a minute while we get ready for the Q&A session. So thanks very much, everybody, and I hope that was useful. Sorry, it's just taken me a good few minutes to do that, but we are getting to the end of our list. Right then, I think we are there. So what I'm going to do is absolutely unmute absolutely everybody now, so everybody can say something. Oh no, I've muted you all by accident. So you were on mute. You can unmute yourselves if you can still hear me. That means you are still in the game. So feel free to unmute yourselves now and say hello.
Yes, hello.
Hey, that's excellent.
Hello.
Lovely. I'm also going to go around and unmute people myself, whether you like it or not. Great. So now I have everybody live. So we've got about 10 of our members in the room, which is really great. And so I would just like to kickstart by doing a quick list. I think who I see we've got. I've got Sean, I've got Alexandra from Jordas, I've got Antoine from Cellulose, we still have David, we have Gregor from RAS, we've got Yuri from the Czech Nano Industries Association, we've got Kai Paul from Blue Frog, and we have Matthew still, and that's about it. So Matt, thanks very much indeed for the presentation. And did you recognise anything that you saw from Gregor's presentation during it? Was that familiar to you, the technologies used?
Absolutely. Well, Freudenberg are one of the largest nonwovens companies in the world. I think the second largest, and the Evolon technology has been used in many applications. Is a nonwoven based technology on water splittable segmented pie fibers. So yeah, it was very familiar. So it was good to see.
No, it's really good, and I think well, I know Gregor works very hard with their clients for whom they are incorporating nanomaterials. So it's very much it's not just a sales process of nanomaterials, but a sort of joint R&D process to get them in there and get them supported to the market. But let's see, does anybody have any questions for Matt? I'm very happy to go and get his slides back out if people would like to look at them.
Yes, this is Antoine. I do have a question for you, Matt. I'm just curious. So do you focus, does your institution focus mostly on manufacturing fibers, or do you nanofibers, or do you sometimes use externally sourced nanofibers? And just for some background, I'm curious about specifically cellulose nanofibers, whether you've used them in the past.
Yeah. So I suppose we would see ourselves as a product design consultancy. So we're not really manufacturing on a
Okay.
large scale basis. We're using small scale equipment to produce fabrics and test fabrics, which can then be scaled up later.
Okay.
And cellulose nanofibers, yeah, we've come across quite a few of those, either via solution spinning or spin blowing, but also splittable. So a lot of natural fibers are splittable into nano components.